Welcome to qnawire.
In this question, it is about speed deamplifier. So we have a flat surface and then 3 blocks. Okay, M1, and then M2 is 2M1, and then we have M3. Okay, M3 is 2M2, so this is 4M1. Okay, so M1 is approaching M2 with a speed of 4 meters per second. Okay, so and all the collisions are elastic. We want to find the speed of block 3 and compare the speed, kinetic energy, momentum of block 3 to the initial values of block 1. Okay, so to solve this problem, so we recognize that this is an elastic collision. So 1 and 2 collides elastically. So and since V2I is 0, okay, so for elastic collision, first we find V2F. Okay, V2F is equal to 2M1 divided by M1 plus M2 V1I. Okay, so we have M2 is equal to 2M1, and then V1I is 4 meters per second. Okay, so we can calculate V2F to be 2M1 divided by M1 plus 2M1, okay, times 4. So this is 2/3 times 4. Okay, we have 8/3, which is 2.67 meters per second. Okay, so this V2F will be the V2I for the collision between 2 and 3. Okay, 2 and 3 collides elastically. Okay, so there's no S. Right, so we'll be using V3F is equal to 2M2 divided by M2 plus M3 V2I. Here the V2I is V2F. Okay, V2I is 2.67 meters per second. Okay, and we have M3 equals to 2M2. Okay, so V3F is 2M2 divided by M2 plus 2M2 times 8/3. Okay, so we have 2/3 times 8/3, which is 16/9 and 1.78 meters per second. Okay, so this is the speed of block 3 after the two elastic collisions. Then in part B, you want to compare V3F with V1I. Okay, so you can see that V3F is 1.78 meters per second, V1I is 4 meters per second. So V3F is less than V1I. Okay. Okay, then in part C, we want to compare the kinetic energies. Okay, so we can calculate K3, which is half M3 V3F square. So half, so M3 is 4M1. Okay, V3F is 1.78 square, and you calculate this, you get 6.32 M1, and then K1 is half M K1I, half M1 V1I square. So we have half times M1, V1I is 4, okay, so this is 8M1, okay, and so K3 final is less than K1 initial. Okay, so less than. Okay, in part D, we want to compare the momenta. So, um, so P3F, the final momentum of block 3 is M3V3F. So this is 4 times M1 times 16 over 9. Okay, so you get 7.11 M1, and then P1I is M1 V1I, and just this is for M1. Okay, so P3F, the final momentum of block 3 is greater than P1I. Okay. Okay, so this is the answer for part D, and that's all for this question.